In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started.
Okay, in this problem we want to start off with S-butan-2-ol, treat it with tosyl chloride and pyridine, and then in a second reaction treat it with sodium hydroxide. Then we want to look at the stereogenic centers in both the final product and the starting material and see what the relationship is between the two. So let's get started. Let's draw butane out, and we'll just say carbon 2 is here, and we want to draw butanol, where carbon 2 has the S configuration. So the way I like to start out is draw hydrogen always on a dash, draw my groups or other groups on wedges and lines, and then just take a look. Maybe we've lucked out here and drawn S. If not, I'll reverse things and fix it. So let's go ahead and label the priorities. This is priority 4 because it's the lightest. This oxygen is priority 1. This carbon has additional carbons attached to it, and this carbon is 3. So this is 1, 2, 3. As I go clockwise, that's R. So that's not what I want to draw. I want to draw S. So what I will draw over here is a molecule that has the OH going on a dash and the hydrogen going on a wedge. So this is R, okay? So the configuration at this carbon is, the configuration at this carbon is now S, all right? So over here it's R. Over here it's S, okay? Again, you can make the enantiomer by switching any two groups, and it will invert the configuration from R to S or S to R. So this is what I'm starting with here. And we want to treat this with toluene sulfonyl chloride in pyridine. And remember that in this reaction, there's no oxygen-carbon bond being broken. So what you get is the tosylate. That's still the S configuration. Okay, and then we treat this with sodium hydroxide. So when this is treated with sodium hydroxide, we need to think about what's going on here. The tosylate is a good leaving group, and the hydroxide is going to act as a nucleophile and displace that leaving group, and this is an SN2 reaction, and the reaction happens by inversion of configuration. So what we want to do here is draw the OH as a wedge and draw the hydrogen as a dash. All right, in this step the stereogenic center is inverted, and we've made R2 butanol, or R butan-2-ol. And if you compare the starting material with the product, you can see that the relationship between these two molecules are enantiomers. So by this two-step synthetic sequence, it's a slick little way to invert the configuration of your starting alcohol. So if we were to start out with the R butan-2-ol shown here on the left, and we followed these two synthetic steps, we would actually end up with the S butan-2-ol. Thanks for watching.